Introduction to quadratic functions. So a quadratic function is also called a parabola. That is the U shape of a quadratic function. You'll see here in just a minute that they are actually U-shaped. For the functions, the highest exponent is a 2. They are squared functions. That's why they're called quadratics, because if you found the area of a square, you would square both sides. So this is called vertex form here, and notice the highest exponent is a 2. This is called standard form. We'll get more into those forms, and again, here's the exponent of a 2 later on down the road. Let's look at the basic shape of a quadratic function. So the equation is f of x equals x squared. That is the most basic quadratic function you can have. So remember that f of x is simply just y. So the way that we find our y values is we take our x's and we square them. So if x is a -3, I'm going to take -3 and square it, which gives me 9. If x is -2, again, we take -2 and square it, which gives us 4. -1 squared gives us a y value of 1. 0 squared gives us a y value of 0. And on the other side, watch what happens. 1 squared is also 1. 2 squared is still +4. And 3 squared is +9. So look what happened to our y values. They ended up repeating. They got reflected. So 9, 4, 1, 0, and then you went back to a 1, back to a 4, back to a 9. Let's see what that looks like graphically. So if I plot all of these coordinates, so we have -3, 9's a little bit off my graph, but that's okay. -2, 4. Then we have -1, 1, 0, 0, 1, 1, 2, 4, and 3. And then again, 9 is a little bit off my graph. So in this case, it doesn't make a line, it actually makes a U shape. So this guy actually kind of doubles back on itself. So instead of a line, it looks like a U. And that's because of the squared in the exponent. Now let's take a look at domain and range. So let's look at domain first. So furthest left. So this arrow does tell me I will be moving left forever. So I'm going to be going towards -infinity forever. This arrow over here tells me I will be moving right forever as well. So similarly to a linear function, my domain is -infinity, less than x, less than infinity, which we remember is simply all real numbers. I can have all the x's possible. Now let's look at range. So range, well, I don't actually move down forever anymore. We have a low point here. So this is my lowest y value possible at a 0. So my range will be 0, less than or equal to y. And then the highest my y values go is both of these arrows here are moving up towards infinity. So the highest y value I have is actually infinity. So the way we write this a little bit easier is think about it this way. This is the lowest number that you can be. All of your graph is above that value. So if we're above that value, that means it's going to be a greater than or equal to. So a little bit easier way to write this is simply all the y's above greater than or equal to 0. That's a little bit easier way to write it. And even if it was upside down. So let's take an example that was upside down. We would take whatever this y value would be. All of your graph is below, so that would be a less than or equal to. So this would be y less than or equal to whatever that number here is on the y value. So it works both ways for upwards facing parabolas and downward facing parabolas. Let's look at some more attributes. So we have a bunch of labels here. So first, let's look at the label that we have called number 1. So number 1 matches this coordinate, this purple point, on both of these pictures. So number 1 is called the vertex. Now, it is a coordinate point, but we call it something special. We actually use h and k instead of x and y because it's a very special coordinate. This is the highest or lowest point on the parabola. If it's the high point, it's called a maximum. And high points look like this. It's the upside down parabola. That means the vertex is actually the maximum point on the parabola. If it's the lowest point, we call it a minimum. And it looks up, it's actually a U facing, upward facing parabola, and the vertex is the lowest point. And that's why it's called a min. So the vertex is where the graph turns, it's that U shape. Related to the vertex is something that we call the axis of symmetry. So that's number 2. So we have this little imaginary red dashed line. Doesn't have to be red, it can be any color. It's an imaginary dashed line, so it's a vertical dashed line that cuts the parabola in half, directly in half. And this is always x is equal to h. Now, h comes from, so I'm going to put down here too, h comes from the x value of the vertex. That's why these two are related. Your axis of symmetry will always run through your vertex. So if this is the h, whatever number is here will also be your axis of symmetry. For number 3, we have a lot of things for number 3. So number 3 are these green points here. That's number 3. Those 4 little green points. These are called roots, zeros, x-intercepts, and solutions. So there's actually 4 words for those points. And an acronym to help you remember is ROXS, because math rocks. So that's kind of a way to help you remember all the words that mean those 2 points. So roots, zeros, that's this guy, x-intercepts, and solutions. All of these names reference the same points. They're not different coordinates. These are all where they cross the x-axis. And if you can remember that these are called x-intercepts, you will know the definition of the rest because they all mean the same thing. And an x-intercept is where it crosses the x-axis. Also, for every x-intercept, the y value is always 0. So it's some number, comma, 0. And finally, we have this orange coordinate here, number 4, and that is where the parabola crosses the y-axis, which is called the y-intercept. In this case, the x value is 0, so it's always 0 and then a number. And there are no special names for the y-intercept. So those are basically the 4 pieces of a parabola that you're going to need to be able to pick out. We have the vertex with the highest or lowest point, the axis of symmetry, which is that imaginary vertical line that runs through the very middle of the parabola. We have the roots, the zeros, the x-intercepts, and the solutions where the graph crosses the x-axis. And we have the y-intercept where the graph crosses the y-axis. Let's talk a little bit more about those zeros of a quadratic function. So we have kind of 3 possible cases here. We can have a parabola with 2 solutions. Remember that solutions and zeros are the same thing. This means you will cross the x-axis twice. So there's really 2 ways that you can do that. Your parabola may be opening upwards like this, where it crosses the x-axis here and here, or it could open downwards where it crosses the x-axis here and here. However it looks, it has to cross the x-axis twice to have 2 solutions, or 2 zeros. We also have a case where you have 1 solution, and that's where you cross the x-axis once. And again, there are 2 ways that you can do this. Your parabola could either be here, where it just kind of touches the x-axis and bounces off facing upward, or it can be something like this, where your graph faces downwards, touches the x-axis, and bounces off. In this case, the vertex is also the x-intercept. That's the only way that this will ever happen. If I only have 1 solution, we're just barely hitting that x-axis and coming off the graph. And there's also a no solution possibility. This is where you do not cross the x-axis at all. And again, there's kind of 2 ways you can do this as well. You can either be way up at the top part of your graph, or you can be way down at the bottom part. Because these are not a line, this guy comes down, turns back around before you ever hit the x-axis, and then goes back up. This guy on the right comes up, turns around, and goes back down before you get anywhere near that x-axis. So there's our 3 possibilities. 2 solutions, 2 zeros. 1 solution, 1 x-intercept. No solution, doesn't cross the x-axis at all. So let's look at some problems. So number 1, identify the attributes of the quadratic function shown below. So we're going to identify vertex, max or min, AOS, which I will get to in a minute, roots, domain, and range. So the vertex. So the vertex is that highest or lowest point. So where you have the U shape, that's your vertex. So my vertex is a coordinate. So 1, 2, 3. So -3, comma, 1, 2, 3, 4. -4. So my vertex is at -3, -4. Now, is that vertex a max or a min? Well, because this is the lowest point on my graph, that means this vertex has to be a minimum. AOS stands for axis of symmetry. So let's actually put that on the top part of our notes. So axis of symmetry is abbreviated with AOS because as mathematicians, we don't want to write axis of symmetry over and over and over again. So what is the axis of symmetry? Well, it's the vertical line that cuts this parabola in half. So it has to go straight through the vertex. So it's this green line right here down the middle. So because it's a vertical line, it is always x equals. That's how vertical lines are written. X equals a number. Well, which number? We need to look at the vertex, and it's always the x value of the vertex. That's why it's x equals. Now, the next thing asks us for roots. So remember that this is rocks. All of those things mean the same. And I know that x stands for x-intercept. So if you're asked for a root, you're simply asked where the x-intercepts or one intercept is. So we actually have two x-intercepts in this case. And so we're going to need to write two coordinate points. -1, 0, that's this guy right here. And also, comma, this coordinate here at -1, -2, -3, -4, -5, comma, 0. So there's two roots for this one. Now let's look at domain. So domain is the furthest left my graph will go. So these arrows don't just stop. This arrow still moves left towards -infinity. This arrow moves towards right towards positive infinity. So my domain, -infinity, less than x, less than infinity. Or you can simply write the double barred r for all real numbers. Okay. Finally, it asks us for range. So what is the range of this graph? Well, let's think. We already said we had a minimum point. So the lowest y value possible is here at this orange line. That's my lowest y value. All of the other y values are above that coordinate point here at -4. So since all the other y values, my function itself, that parabola, that u shape, is above the y value of -4, that means my range has to be y greater than or equal, because above -4. So I'd like you to pause the video and I would like you to try number 2 on your own. And here's your solution for number 2. Our vertex, -4, 0, it is a max because it is the highest point on our graph. And notice the solution, remember solutions are still part of that ROXS acronym, ROXS, and it's an x-intercept, is also -4, 0. These are the same thing this time because it's simply the vertex is the only place that this graph touches the x-axis. And then the y value, or the range, is all the y's less than or equal to 0 because this is the highest point possible and your graph is below the highest point, so that would be a less than or equal to. Pause the video, try example number 3. Here's your solution for number 3. Vertex is at -3, +2, and it is a minimum because it is the lowest coordinate. The axis of symmetry is x equals -3. It is this vertical line that runs right through the parabola. This time, our rocks, ROXS, we actually had x-intercept. That's the easy one. That means there isn't any in this case because this function here, this parabola, never intersects this x-axis. So there is no x-intercept. The domain is still all real numbers because this always continues left, this always continues right. And the range is all the numbers larger than the y value of 2. All numbers greater than or equal to the y value of 2. Let's look at number 4. What if we have to go backwards? What if I have to draw the graph based on some given information? So I would start by plotting what we do know about this parabola. So graph the parabola with the given vertex and zeros, answer the other two parts. So I know the vertex is at 4, 3. So 1, 2, 3, 4, 1, 2, 3. Now the zeros, if you don't know where to plot those coordinate points, remember that zeros is simply another name for an x-intercept. So 2, 0 is one x-intercept, and the other one is at 3, 4, 5, 6, 0. Now I can kind of see the basic shape of my parabola. I have 3 points and I can kind of connect these in a relative U shape. Is it a max or a min? Well, the vertex is at the top of my graph, which makes it a max. The axis of symmetry still has to run straight down the vertex. And so we have an axis of symmetry of x equals 4 because it's always the x value of the vertex. Domain is still all real numbers. This is going left forever, so that's negative infinity. This portion of the graph moves right forever, so that's positive infinity. And so you can either write it in inequalities or you can use the all real numbers symbol. And then finally, what's the range? Well, the lowest value, if you want to start there, the lowest value is negative infinity. The highest value is this vertex here at 3. So since I have a boundary, let's write it the simple way. The highest number is 3, and all of my y's are below the y value of 3. And if we have below, we have less than or equal to. Now let's look at some tables. So 5 and 6. So now we have a tabular representation of quadratic functions. So you have a couple options with this. You can kind of sketch a graph, or you can look at the values. A quadratic function is shown in the table below. Identify the requested attributes. So for this first example, I'm going to kind of sketch this graph to help you see the pieces that I'm pulling out. So here's my little x and y axis. So the first coordinate I have is negative 2, 5. So negative 2, 1, 2, 3, 4, 5. So I'm just going to sketch it out so you can kind of see how this is moving. Negative 1, 0 would be here. 0, negative 3 would be here. 1, negative 4. 2, negative 3. And 3, 0. So it kind of looks something like this a little bit. So when it asks us for the vertex, I know it's going to be this coordinate here. Now notice what happens. So I started graphing up top, and then I kind of lowered my y value, and then I lowered my y value, lowered it one more time, and then I started moving up again. These are at the same y value all the way across. So my vertex is directly in the center of my graph. So let's look at my table. 5, 0, negative 3, negative 4, and then negative 3 again. I repeated the same y value twice. So this coordinate here in the middle of my repeating y values, that has to be that vertex. That's that turning point. That's where your graph starts to go back up and create that U shape. Otherwise, you would have been kept going in a line. But since my y value started to repeat, I had to move my graph and turn my graph and create a U shape. So my vertex is 1, negative 4. Find the coordinate in between the repeating y values. Now, is it a max or a min? Well, if I have the graph, it's really simple. Since it's sketched already, I can easily see that this vertex is the lowest coordinate on my graph, so it has to be a minimum. But how do I tell from just looking at the table? Well, look at your y values again, because when we talk about max or min, we're usually talking about y values unless otherwise stated. So let's look at the y's. 5, 0, so these are decreasing, 0 to negative 3. Negative 3 to negative 4 decreased, but then negative 4 to negative 3 increased. So we're moving down, down, down. We hit the vertex and we come back up. So even if you don't know exactly where the coordinates are, because these y values are all decreasing, this y value is all increasing, we know it has to be an upward facing parabola, which makes this vertex a minimum, the lowest coordinate on your graph. Again, you can always make a sketch to kind of get a better idea of what this table represents. So now for the axis of symmetry. Well, since we have the vertex, that one's really simple. The axis of symmetry is always x equals, and because it has to run directly through the vertex, it is always the x value of my vertex, which is 1. For the zeros, so remember, zeros is part of that rocks, and that just means x-intercepts. X-intercepts always have a y value of 0. So find your y value of 0, and this would be 1 x-intercept. Make sure you don't have any more. Here's another one. Here's another x-intercept at 3, 0. Be careful because this one here is actually a y-intercept because the x value is a 0. Now let's talk domain and range. So when it tells you that it's a quadratic function, remember that that can either be facing up or it can be facing down. And the arrows have to be on the ends. So no matter which quadratic function you have, the domain is always all real numbers because it always goes to the left and the right on our graph. Now the range, this depends on your vertex. As we have seen in these previous examples up top, we find the vertex, that's either our highest or lowest coordinate, and then we decide if it's greater or less than that number. So when we have a table, we already found the vertex. We found that this -4 was the lowest point on the graph. So all of your y values had to be above -4. So all of your y's have to be greater than or equal to -4. Turning this table into a sketch is going to be extremely helpful in solving these problems. Pause the video and try number 6 on your own. Here's your solution for example 6. In a later video, we will do 7 and 8.